Okay, Wildcat, segment at 1. Blame it on the rain. Modeling with functions. The student works the warm-up. Right, let's take a look at the next page. All right. Go ahead and mark out this page. All right. 1.1, modeling a problem situation. The sheets of metal being used to create the drain are 8.5 feet wide. The engineer wants to identify possible heights and bottom width measurements she could use to construct the drains. 1. Define a function w of h for the bottom width given a height of h using Desmos regression. So first, if you would, go ahead and complete the table. Now, when using Desmos regression, since this point's not possible, we're going to mark this point out. We're not going to use that point. Okay? Alright, so let's go ahead and plug these numbers into Desmos. So I'm going to click the plus sign, table, and then 0, 0.5, 1.25, 1. Alright, now let's go ahead and adjust the window so that the points match the graph. So I'm going to wrench. Let's go from 0 to, it looks like 3.25. And then let's go from 0 to the highest number, 8.5. So 8.5. Alright, and then we can zoom out just a little bit. There's our points. Now we're going to press the regression button right here. And then there is our equation. Now we're going to use h instead of x. So w of h equals negative 2h plus 8.5. Go ahead and write that down. Let's take a look at the next page. To determine the drain dimensions that allow the most water to flow through, the engineer must calculate the cross-sectional area. The cross-sectional area of the drain is shown. Three, describe how to determine the cross-sectional area of any drain. To determine the cross-sectional area, I need to multiply the height h by the bottom width, negative 2h plus 8.5. So the cross-sectional area is the equation a of h equals h parentheses negative 2h plus 8.5. Number 4, graph a of h equals h parentheses negative 2h plus 8.5 and describe the drain with the maximum cross-sectional area. Alright, so let's go ahead and do that. So I'm going to exit out of this, press the home screen. Now we have to use x instead of h, so x parentheses negative 2x plus 8.5, and I'm going to zoom out just a little bit, and then there is my maximum point, which, let's go ahead and round to 1 decimal place. So okay, so the maximum cross-sectional area is 9 square feet, which occurs when the height is 2.1 feet. All right. Go ahead and mark out the rest of that page, and let's take a look at the next page. 7. Analyze and interpret your graph. A of h equals h parentheses negative 2h plus 8.5. A, what is the maximum cross-sectional area for the drain pipe? Which we've already calculated, which is 9.0 feet squared, which occurs when the height is 2.1 feet. B, identify and label the intercepts of A of H on the graph, then describe the meaning of each in terms of the problem situation. The x-intercepts. So we're going to go back to the graph. My x-intercepts are 0, 0, and 4.250. So the x-intercepts are 0 feet squared, and let's round to one decimal place, so 4.3 feet and 0 feet squared. And then the y-intercept is right here, which is 0, 0. And so the y-intercept is 0 feet squared. All right, go ahead and finish up 7A and B. C, identify and label the equation of the axis of symmetry on the graph. Then describe the relationship between the axis of symmetry and the maximum cross-sectional area. So the relationship is we find the maximum, that's our vertex, and our axis of symmetry is x equals, in this case we have to use the exact number, 2.125. 2.125. Can't round because it has to be the exact point to cut the graph exactly in half. Okay? All right, go ahead and mark out the rest of that page, and let's take a look at the next page. All right, mark this page out. Mark this page out. Go ahead and mark out this page. Go ahead and mark out this page. Go ahead and mark out this portion, and then the student works 1A, 1B, 2A, 2B, and 3. All right, go ahead and finish up your notes, start working on your assignment, and have a wonderful Wildcat day.